Namaskar. I'm from Bhavnagar. It is around 200 kilometer away from Gandhinagar. From the CSIR lab, Central Salt and Marine Chemical Research Institute, Bhavnagar. It is one of the CSIR constituent laboratory located in Saurashtra region of Gujarat Saurashtra region. The main mandate of the institute is salt and marine chemical. So we are working on marine based inorganic and water desalination and membrane technology. I can say that in membrane institute started membrane technology in 1970s. And those days we have different kind of membrane, rubber membrane, other thing, because there was little knowledge of advanced polymer technology. But now we have commercialized several type of membrane. Indigenous membrane, that is a matter of proud, buy from multinational company and use the membrane. That membrane produces in the country seawater desalination, RO membrane, brackish water desalination, NF membrane, hollow fiber membrane and ion exchange membrane. So that total spectrum, because we are working on all the technology water desalination, where which technology find suitable. Today I am here to say something about electrodialysis and electromembrane processes regarding water. Ion exchange membrane, initially when RO membrane was under development, was Professor Sauri Rajan. Professor Sauri Rajan is the pioneer person for the RO membrane. He first invested that is from India. It is a matter of proud. So that time we have our rubber membrane, rubber ion exchange membrane. We mixed the ion exchange resin in the rubber matrix and used as a ion exchange membrane. But that membrane was very good at that time, but today it is not. Now very advanced type of ion exchange membrane was developed. Actually here I may, because I won't show that slide also because it is beyond the scope. Whole country, if you are talking about the ion exchange membrane, Nepean cation exchange membrane is the state of art membrane for the whole country, developed by DuPont. And all chloralkali, energy, fuel cell, storage battery, all based on the Nepean membrane. But the Nepean performance of the Nepean membrane in these processes is not up to the mark. In last 3-4 years, I am working with the ONGC Energy Center for developing a substitute of Nepean membrane, and I very proudly we patented the fluorinated carbon membrane developed at my institute, and it has been tested at BARC by Professor A.K. Tripathi group and ICT by Professor G.D. Yadav Sahab group. And now it patented the indigenous development that will boost the membrane technology in the country. But lot of Chinese membrane here, there, membrane, you go and put a module. This is not the solution of problem. Multinational technology is available. What indigenously we are developing in this country. So this are the application: water desalination, fuel cell, industrial application, and biotechnology, food juices, where you are de-acidification all the sweetening of the juice. Bipolar membrane, that is water splitting, converting salt into corresponding acid and base. This is the new field, hydrogen generation, because energy, this is going to be future. All countries running the hydrogen powered buses and vehicle. We are struggling in the R&D process, how to produce the hydrogen, and the hydrogen safety regulation is very, so that will come up certain. So, and electrodeionization, I will cover this because we have developed the indigenous system. So this is very common. Ionization membrane should be very good selective for the cation, and anions should possess the low resistance because it is electrochemical process, and because for any commercial application the membrane stability, chemical, mechanical, and high dimensional should be very high. So this is all the requirement of the ionization membrane. We develop the membrane and commercialize this membrane, styrene divinyl benzene, polystyrene, and copolymer with interpolymer with polyethylene, polystyrene divinyl benzene, and we are making the copolymer. Then copolymer we are sulfonating to introduce the sulfonic acid group, and then we are making the thin film membrane. I will show the photographs. And similarly, we are making the cation anion action membrane here by grafting the quaternary amine group. This is our indigenous process and patented also, and technology has been transferred also. This is the photographs. This is a polymer making machine. Actually, we have facility up to 10 kg per batch, and for polymer making now company we have transferred the technology, and this is the polymer beads, and it is blow film extrusion of the in the form of thin film, casting thickness around 150 to 200, and then sulfonation and chloromethylation. This is the end membrane. We are making into 5 meter, 6 meter, 10 meter, not continuous. So this is batch mode production, and this membrane has been used for different application, indigenous membrane. And if you see the property of this membrane, best available world best available Neosepta and Asahi glass, and Nepean is the I told Nepean, but this membrane cannot compete Nepean membrane because it is fluorinated hydrocarbon. Only for property size it is Neosepta and CMB. It is also styrene divinyl benzene based membrane. Composition is same. They are using PVC binder. We are using high density polyethylene binder. Only difference is binder and how to make the thin film membrane. Now we are working to melt processing also. So this you see our membrane is not inferior than in by electrochemical properties with any of this and here no anion action membrane, non-fluorinated carbon anion action membrane is not. Why I am talking about fluorinated carbon? If you go fuel cell application or other energy application, there will be water splitting, highly oxidative species there. So this oxidative species will attack then the aromatic ring and create deterioration, degradation of the ring by electrophilic substitution reaction. So that's why if you are going for very high energy application, you need aliphatic carbon chain. I will show the graph afterward is there. How Nepean membrane we are competing with the Nepean membrane. This I am talking about the water business. Then I will, one graph I will say. So here we see the property, electrochemical performance and property is similar, and the membrane cost is I think much cheaper. This membrane 25,000 rupees per square foot, and my cost is 2,000 rupees per square meter. Indigenous cost. So this is the cost difference in the membrane cost difference, 2,000 rupees per square meter, including manpower, everything, all the things. And if you go to purchase the membrane, it will be 20 to 25,000. It depending upon the brand, Neosepta or Asahi or whatever. This is the principle of electrodialysis. This is used for a student how ion is getting dipolarized under electrical polarity, and one stream become treated and one other become concentrated. So this is the because now then by managing the flow rate of this different stream, we can get 70 to 65 to 70% of the product water, and 30% will be the reject water, managing the flow rate of this stream. And based on this principle, this is the some thing how you can, and this is performance of membrane. It is very science science related, not technological. Here, based on this membrane, we have expertise to fabricate the electrodialysis unit. This is 120 cell pair, means 120 cation action membrane, and 120 one cell pair means one cation and one anion action membrane, 240 membrane with the suitable spacer, membrane spacer and membrane gasket. And this is indigenous. If you go on internet and buy this unit, the cost will be very high, but our cost is few lakhs. Not very high. It is affordable for a very 7 to 8 lakh this type cost, and this is regularly operating for the water desalination or water treatment. So we have and different TDS we can deal, and basically if you see water is definitely a problem, the coastal belt. But if you go rural area, water desalination is problem belonging from the eastern UP. Water level is very high, but you cannot drink the groundwater without purification. All over India, water purification. Now RO, small RO unit become a house piece. Every house is having water treatment, and this is the way how we can cater the thing, how we can improve the technology. Big plant is okay for industrial application and nothing, but think about common man. This is the thing how we are serving in the village. This is the thing of Tamil Nadu, and here we see this plant, very interesting plant. This is the small, actually 20 kilometers away from Bhavnagar, there is a village near coast. It is a half kilometer away from the Indian coast. The village population is around 2,000. Very pure person. They are मच्छी मारने का काम करता है, all the thing. And 80% population of the villager, they were having the stone problem due to the water hardness. What they are drinking very water with high TDS and high hardness. Okay. So this hardness problem, and electricity is also now, and who will pay the electricity? That is also problem. Electricity ka who will pay the bill? We surveyed the village, and this type of village, at least we are working in 10 villages in the coast. We establish a small panel. You can see the panel. This is the solar panel. And with this solar panel, this plant can be operated for 10 hours. The plant output is 300 LPS, means you can get 3,000 to 4,000 liters per day, and this is catering the drinking water problem for the village. Only drinking water. So this, you see how lady and gents coming and regularly. And since 2 years, in March it will complete 2 years, the plant is going on. Our team is going once in a 4 months and check the output is okay, nothing, there is no problem. One villager putting on and off, that's all. Put one switch and no thing. We use the hydrostatic pressure for this, that overhead tank. You see how we made overhead tank. That hydrostatic pressure is used to flow the different stream, and this type of thing is implemented now in 10 villages. So at least this is giving the what actually we are doing for the society, from which taxes we are being catered. So this is the thing big company, big industry, poor people, if you go in the rural, you see their life is very pathetic. Now, this is now one. Actually, overhead tank, for that they are pulling the water from the kuwa, from the well. So from that well, we directly feeding the overhead tank. not surface, that we give the 3-4 meter height. Now, what is the benefit of the electrodialytic water desalination over reverse osmosis? I am considering only for drinking water. You see, RO removes everything. Means the TDS of the RO, if you treat, it will be less than 100 ppm. And big companies, they are claiming TDS controller are added to salt. Means drinking water में बाहर से salt add करता है और TDS controller. This is very good brand. I have taken this from their website. How they are using RO brackish water and they are bypassing they are treating by RO and bypassing one stream by UF, and this used as a TDS controller. The TDS controller is only due to NaCl because all the TDS is due to the NaCl. And as you know, कि other minerals is also essential for our body. Actually, this idea came in 2008. A article appeared in the Nature. Then we thought that this is very essential problem, and we developed the monovalent selective ionization membrane, which only removes NaCl. NaCl is undesirable. Rest of mineral is desirable for the human body. And if you see the WHO and different agency recommendation, the drinking water composition of different times should be this. NaCl, TDS, now this Indian standard increase up to 1000, but it is 300 to 500. And NaCl, sodium, magnesium, calcium, potassium, chloride, sulfate, carbonate, bicarbonate. And natural water, actually we surveyed, took the different water, natural groundwater at different location. The TDS varied from 3000 to 5000. Here data is around 3000. The TDS is this, and mineral water composition is this. And this we purchased not our unit, from market we purchase a unit, and this is the, I'm not disclosing the name because it's commercial unit. You see the composition of the RO product water, and then we did for the electrodialysis. The composition was slightly improved, but not up to the mark. To improve this thing, we developed the monovalent selective RO membrane, and here you can see this is the ideal concentration, this is our improved technology, electrodialysis, and this is RO. So you see how this ionic composition is complying to the ideal concentration. Means this we immediately patented. We are negotiation in the technology transfer. And most important thing, if you go on Google and put the alkaline water. Now alkaline water, those who can pay, the cost is very high, 50 rupees, 60 rupees per liter in if you go in the mall, alkaline water. So by simple managing, actually the principle of alkaline water, ki earlier we are drinking soda, khawa soda, calcium bicarbonate, that is soda. So that was increasing the alkalinity. But now the thing, by increasing the pH to 8.2, it will be very good for the tiredness and anti-acid and all the things. So by managing and the traditional to make the water electrolysis, so that we are achieving in our electrodialysis unit by managing the potential. So we are able to produce the product water of 8.2 pH and with all this mineral content. So that means nutritious, because these calcium, magnesium, these are the micronutrient for the human, for plant, and alkaline. So this technology is a unit we designed, because our design is unit, and the output of unit is 20 liter per hour, and we are working to improve the thing also. So this is the one where you can get quality of product, where and the cost is not very high. the cost of the unit is 30,000 at present, because our in the workshop fabrication, if you go in the commercial house, it will further come down, and energy consumption is around 3 to 4 kilowatt hour per m cube, or 1.2, I think 1 to 2 kilowatt hour per kg of salt removed. So this is the next key where we can get the quality of drinking water, because all the minerals are naturally available, and we should and if you are adding anything from the external side, it if I see it is against the Indian ethics कि बाहर पानी में बाहर से ऐड करता है, तो that may carry the impurity also. So don't you add impurity, only remove the undesired constituents. This is the unique feature of this unit, and the development is now I am switching Ultra Pure. Two story I will share and close down. Total business of Ultra Pure water is captured by the millipore. The millipore business is around 500 crore per year in India. And electrodeionization, you see, there will be the ionization resin will be packed in the between the treated stream, and it will remove, and they are using the advantage of concentration polarization across the membrane to regenerate the resin in situ. By water splitting, it will produce the hydrogen and hydroxyl ion, which will remove the anion and cation in the resin. So in situ regeneration is going on, and the ultra pure water is 18.2 mega ohm with no additive, only in inert atmosphere. If there will be carbon dioxide, so the resistivity will decrease due to the formation of carbonic acid. So with the principle of this, we initially fabricated 15 liter LPS unit, and this 18.2 TOC1 ppb, PS7, fluorate 15 LPS per day. So equivalent, the cost of this unit is around 50,000 of production cost, and if you go millipore unit, the cost will be around 8 lakh rupee, and total country depending, because now all medical, pharmaceutical, semiconductor, all industry, the ultra pure, and I am thankful to Professor Tiwari. He was in the committee of DST, and he given us a project to further scale up this. So with his support, we further scaled up this is the water. This is we scaled up. This is open. This is RO. Actually, brackish water to more than 1,000 or 2,000. We are passing through RO, through filter, and then pre-treatment filter, then RO, and then around 100 ppm water we are passing in EDI unit. I will show the detailed figure. It is in black, and this EDI unit is treating and giving 50 LPS. So this is we have supplied around 100 unit to different country, because our confidence building, and we are measuring the water quality. One side we kept the millipore unit, one side our unit. What is the water quality with different season and variation, so that before now it is working on the technology is difficult, but commercialization is technology is much more different than the developing the technology. So we are struggling in between. Technology has been developed, and for the commercialization of the technology. So, and you see our water ultra pure, our and millipore system. So both are nearly same, there is no variation, and this is also a very good, because millipore 50 LPS, I don't think they are available 10 LPS. ADI. But I will show what is their mastermind. This is our unit diagram. This is unit. It is tightened by nut and bolt, but their unit is molded. If once it get wrong, you have to throw total unit. And if anything went wrong, because there is membrane, any membrane can get the puncture or there may be hole, so no need to throw the membrane, open, replace that membrane. So this is complete Indian ethics. We are following not use and throw method. We follow the Indian ethics, reuse it. Huh? So, and this is the clear picture of EDI unit. This is the electrode chamber, and this controls the flow of two stream, and this is the hole for nut bolt. It is nut bolt tightened by nut bolt, and it is going on. We ensure the lifetime of 3 years, but let us see. Flow rate depends upon the design. How you are giving the slit hole area and piping and all the things, hydrodynamics of the unit. We developed 10 liter, EDI unit of 10 liter and 50 liter. Now we are working for 100 liter. So our target is 100 liter because you see this is different from the DM water. If you add the DM water, the flow rate will be high because going DM water is less than 10 microohm, going less than 10 to 18.2 is very difficult task. So that DM water is okay. DM water, so I am talking about ultra pure, which is highest resistivity water without any contamination, so that all these surgical tools, pharmaceutical, making injections and this tika, all the things. So we are working with the Bharat, Hyderabad mein, Bharat, they are making polio tika and all the things. So this water being used there. Feed quality is, we are working with the groundwater. Our groundwater is around 2000 ppm. So 2000 ppm we are passing through the pre-tilt treatment, then RO unit. RO it making less than 100. Maybe 75. It depends upon कि बरसात में तो 50 तक आ जाता है, but in summer it will be 175. It depends upon the season and groundwater quality. So I am treating above 50, lower below 100, and that passing to the EDI, so that load on the EDI should be low. You consider 75 ppm as a marginal value, and the quality is this. Now, one very shortly I will say two stories. Sustainable development means water treatment and energy for the family. These are the two sustainable requirements for any rural village. If you provide them, they will be happy. Modi साहब तो घर दे देते हैं. House is, they are building the house. Now they need energy and water. So this is the idea कि by solar treat the water, and same thing by RED, reverse electrodialysis, will high concentrated. Suppose your waste is 50,000 and use some water for this, the concentration gradient will be 50 times. So according to nurse equation, this much potential you can get. So using this very basic equation, we generate the potential. We tested the unit 100 watt. So that we are confident कि means by electrodialysis there may be sustainable development. Don't use any solar से, operate the urine unit, and then R&D. And this I may finish. These are the sub-chemistry, high chemistry is there because nothing was going without basic science. And this is the unit packaging, dimension, anything, everything. This is. Now, this membrane, recovery of the fusion mass.
So how about sharing this experience during our panel discussion?
I'll provide our PPT. And if you need specific, I'll provide you write-up. A specific topic, suppose you are interested in, I am sharing so many stories. If you are stuck on one story, I will provide the detailed write-up. In 1.5 minute. So this NaOH recovery fusion mass, very costly unit, and this unit being tested in Vietnam by Aquatherm. They took the unit from us and sent Vietnam. This is a pilot scale. Now they are adding, but we are R&D. No need big bada nahi kar sakte. 1-2 unit we can make, not more than this. And now this is the reduction of sodium, this ammonium nitrate. I am working with the Rashtriya Fertilizer Limited, Bombay. They sponsored the project because their waste stream में बहुत ज़्यादा ammonium nitrate है. Nitrate disposal is a very problem and it is very good resources. So how to concentrate and reuse this ammonium nitrate. SHNO3. And one slide I missed, some thing, this metathesis conversion of ammonium nitrate into nitric acid and ammonium hydroxide. So that is a BRC problem in uranium extraction division. I am working for there in uranium ore mines. During processing, lot of ammonium nitrate is how to reconvert and reuse the process. And with this what I metal electroplating, all the bivalent can be easily without any fouling. In this, fouling is not also problem. If there is a fouling, give reverse polarity for the reverse polarity. Fouling will detach on the membrane. The membrane life will be secure, and I should be. And also I promise the Nepean. This is the Nepean structure, this is the mine structure, this is the and this has been patented. You see, same side chain, fluorocarbon, sulfonic acid, side chain, sulfonic acid, fluorocarbon. So very cleverly managed here and there within so many copolymers. I didn't do fluorine chemistry because in India doing fluorine chemistry is not thing. So I should be thankful to you and my PhD students. They are the only my hand. So I should be very grateful.